Hello and welcome to a new video. In this video we are going to do exploratory data analysis on Olympics dataset. We are going to use a lot of data analysis and manipulation methods with visualizations. We are going to work with an Olympics dataset and I will provide the dataset link on the description of the video. What I recommend is applying the codes with the video at the same time for learning the codes and how they work better. We can start now. Let's start by importing pandas, Seaborn, and Matplotlib. Let's start by loading the dataset. For this, we are going to say data is going to be equal to the pd.readCSV. Dataset Olympics is our dataset name and we are going to run this. Let's display the first few rows of the dataset by data.head for seeing how our data looks like. And we have the information about the athlete is ID, name, sex, height, weight, team, country, games, season, city, sport, medal winning, event, and we got a lot of information to work with. Let's get the basic information about the dataset by data.info. Info here. From here we can see that we have 70,000 entries, the data types. Our columns contain non-null values, null counts, data types like I said. It seems great. Let's get the summary statistics of numerical columns by data.describe. What we can say from here is ID goes from 1 to 35,658 and mean age is 25 for the athlete is, mean height is this, mean weight is this, and we can see the standard deviation which gives us idea about how data is distributed, and we can see the minimum value for the year 1896 and the maximum year 2016, and it seems great. We have another usage of this describe method where we include the object type of data. So let me show you that. Data.describe, and we are going to say here include, we are going to say object. Okay, what we can get here is we can see the counts here and we can see unique amount of columns, like we have 226 unique countries in our dataset, 51 games, 2 seasons, 42 cities, and the most occurring values, like the most occurring sex is male in our dataset, most occurring country is United States, most occurring game is 2016 summer, probably because it's easier to collect data if the date is closer, because now it's easier to collect data in every site. Most occurring season is summer, most occurring city is London, most occurring sport is athletics, and we can see that most occurring medal is gold, and we can see the frequencies here, how frequent they appear on the dataset, the top values. Like from here we can understand that male appeared 51,000 times in our dataset. And another example, United States appeared 4,900 times. Seems great. Let's check for the missing values. For this we are going to say data is an A and we will say sum here. Now we are seeing the missing data amounts. Actually we are missing data on age, height, weight and medal. Of course deleting the medal is nonsense, because we are not going to change anything about the medal information. We are going to use the data if they don't even have a medal earned. Changing age, like filling the missing values with mean, is no sense. Also this is valid for height and weight, because each of them is unique by athlete. So if we change them or drop them, we are going to lose some necessary information. So it's nonsense. We are not going to do any operation with this missing data, since we are not missing anything critical. Let's check if we have any duplicates in our dataset. We are going to say data duplicated and sum. We have 383 duplicated rows. We can clean them, it's okay. We are going to say drop duplicates, and what we are going to do is we are going to say in place equals to true. So in this way, we don't need something like, also I need to write the true with capital letter. So with this, we don't need to assign it like data here again. In place works in that way. If you use in place, it's automatically changed on the original dataset. So I'm going to run this one, and now we can check if we have any duplicates left with duplicated and sum, and here as you can see it's 0. Okay, let's start with visualizing the distributions. Let's start with, we are going to use Seaborn's count plot, and let's pass data, and let's check the distribution by gender. For this, we are going to say x is going to be equal to the sex here, and we are going to say plt.title distribution by gender, and we are going to use plt.show here. Let me change the title real quick. Distribution. Okay, now it's going to look better, and you can see the distribution of genders in our dataset in this way. Now let's check this for the age. Since it's a numerical column, we are going to use histogram plot for that. Let's get the histogram from Seaborn. Let's say SNS his plot. Data is going to be equal to data. X is going to be equal to the age here. Bins going to be equal to 20. We are going to change this, and we are going to look for how it makes change in our plot. We are going to set this at true. Let's say plt.title, and we will say age distribution, and we will say plt.show again. Here it's actually amazing that some athletes at their age like 90 or 80. So let's change bins here and see how our plot changes with respect to that. Also make this 10, and you are going to see something like the older one. Yeah, that's great. You're going to remember that our mean was like 25, so it makes sense. Okay, let's get to the height distribution. For this, we are going to use histogram plot again, since height is a numerical value. We are going to say data equals to the, also I need to fix this histogram plot. Data is going to be equal to the data. X is going to be equal to the height this time. And we are going to set bins as 20 and set this as true, and we will say plt.title height distribution plt.show. Okay, here we have our graph. We have values like 220 and 140 here, and it seems great. Okay, let's check the weight distribution this time. We are going to do the same type of thing, histogram plot, since our data is numerical, and we will say data x is going to be equal to the weight here. Let's set bins as 20. I generally use that, but it depends on data, and we will say plt title, and we will say weight distribution. I got it right this time. plt.show here again. Seems great. Okay, let's get the medals distribution. For this, since it's a categorical column, we are going to say count plot this time. And we will say data is going to be equal to data, and x is going to be equal to the medal. And we are going to say plt.title, and we will say medals distribution. And we are going to use plt.show. Here it is. They look like same, which makes sense because in a tournament you give 3 of them. In a competition, like if you are giving gold, there's some bronze medal winners and silver medal winners. So why makes this difference? What makes this difference? Let's just assume something that maybe there's 2 winners, like 2 athletes. For example, at running, 2 of the athletes at the same time finished at the same time, and they're both getting gold. So maybe this can be the reason of this. I think like that because there's nothing else coming into my mind right now. Seems great. Let's see the medal distribution over the years. For this, we are going to say count plot again, since it's categorical. Count plot, and data is going to be equal to data. X is going to be equal to the year this time, and hue is going to be equal to the medal for this, and we will say plt.title medal distribution over the years, and we will say x-text and rotation 45, and we will say plt.show here. I think what we thought is true, since there is no big differences between 3 for each year, and we just got the information we wanted. Now let's do some group bys. Let's group by year and calculate the average age of participants, so we can have a good information about our dataset. Let's say here average age is equals to, we are going to use group by method here, we are going to group by year, and what we are going to do is we are going to write age inside the brackets, and we want the mean of that. And let's print this, year average age. It's great, I think. We have the information we wanted. Okay, let's group by sport and let's calculate the median height of participants by sport, per sport. So we are going to say sport median height is going to be data. Again, we are going to use group by, of course. We will group by sport, and we will take the height here, and we will take the median values this time, and we are going to say print sport median height. That seems great. Also, what if we want to take the maximum value here? For this, we are going to say just maximum from here, and we can run like this for getting the maximum value here. Okay, we know the maximum value, but we don't know which sport has this value. So what we can do here is we are going to just do a basic filtering, like we are going to say sport median height, and from here we are going to open brackets and say sport median height equals to this value here. And so with this also it was expectable, I guess, because most of the basketball players most of the basketball players are taller actually. So great, we can also do this for the minimum, just like changing this, and after that we are going to take this value and just use it on here for getting same kind of information. That's great. Let's keep the group by operations. We are going to group by country and count the number of male and female participants per country here. So what we are going to do here is we are going to say country, and gender count going to be equal to the data group by. We are going to open a bracket since we are going to group by 2, and we will say sex also here. And what we are going to do now is we will say ID, and we will use count here, and also print this information. Now let's do another thing, like let's get the most gold winning country. For this we are going to say country gold medals, and it's going to be equal to the data, and we are going to use brackets, of course. We are going to say data medal, where this equals to gold, and what we are going to do here is we are going to group by country here, and we will take the values of medal and we will say count, just like this, and we are going to print this one. We printed a wrong thing here. Let's fix this, gold medals, and we are going to print this one. Let's just delete the extra cell. It's great. So what we are going to do is let's do a similar operation like the last one. Let's get the maximum value, and now we are going to say country gold medals, and we are going to open brackets here. We are going to say country gold medals equals to 747, and we are going to run this one. I'm just going to go up a little bit and I'm going to show you something. This result was expectable because the country mostly participated in this Olympics was the United States, so it makes sense if they win the most. I think maybe it's not that true, but I think it's expectable in my opinion. Here we are going to let's group by sport and calculate the average weight of male and female participants. For that we are going to say sport gender, average, weight, and we will say group by what you know, what we are going to group by. We are going to group by sport and sex, and we are going to take the values of weight, and we will use mean this time. Yes, and we are going to change this real quick because we don't want errors in our output, and let's print this. Okay, you know this information, but what if you want to see specifically for a sport? For this, what we are going to do is, we are just going to add brackets, and let's take for the, I don't know, wrestling here. And we are going to run like this, for seeing the values of wrestling here. Okay, it's great, but what if you only want to take the values of the female participants? For that, you are going to guess it, we are going to open another bracket, and we are going to say female here, and here's the information we wanted. Okay, now let's add visualizations to this group bys. So what we are going to do is, we are going to group by sport, and we are going to count the number of unique events, and we are going to visualize this. So what we are going to do is, we are going to say sport event count, and we will say data group by. We are going to group by sport here, and we are going to take the values of event, and what we are going to do is, we are going to use number of unique here, and we are going to say sort values in descending order. So what we are going to do is ascending false, like this, and we are going to say sport event count and dot plot kind, let's use bar plot here, and we are going to set the figure size as, let's just forget about it, we don't need to change this. I think this is just going to add some complexity, so it's unnecessary. And here it is. Now we are going to use plt.title number of unique events per sport, and we are going to say x label is sport and y label is number of unique events, and we are going to say x text and rotation going to be equal to 45, and use plt.show. We made a typo, I think. Let me fix that. Let me check why is it says bar is not a valid plot kind, but it is. What's the problem here? We need to use lower ladder here, and now it's great. I want to mention that since we have a lot of sports, a lot of events, so this graphs looks complex, and we can deal with this by eliminating some of them, but we are not going to do that since I think it's unnecessary. I'm just showing you how we can plot the whole, and in this way you can just filter some of the sports out, and it depends on your case and questions, I think. Okay, let's move on. Now let's group by year and visualize the number of participants. For this, we are going to say year participant count is going to be equal to the data.group by, and I will say year, and we are going to take the ID here and number of unique, and we are going to set year participant count dot plot, and kind is going to be line this time, and marker is going to be, let's say this, and I think that's all. And we are going to use plt.title number of participants over the years, and x label is going to be equal to the year, and y label is going to be equal to the number of participants. And let's use plt.show here. Here it is. So it looked a little bit different, so there's a lot of chains here. So what we can do else is, let's just remove this, and let's write bar here, and let's rerun this. We can use a bar plot here again, and I think this one looks better. I love data visualization because it makes easier to see values like this. So from here you can easily see that the 2016 have the highest value of participants. You can see the increasing trend of participants over the years. I think it's easier to collect data on all sports over the years, so maybe this can be the reason, but we have the lower values like in 94 and 98, so I'm not sure about the reason of this, but bar plot fitted well. So let's group by country and visualize the average age of participants this time. What we are going to do here is we are going to say country average age is going to be equal to the data.group by, and we are going to use the country, and we will say we are going to take the values of age, so while we are going to write the age inside of the brackets, and now I'm going to say mean, and we will sort values in descending order. So what we are going to do is ascending false again, and now this time we are going to do something different. Let's take less data here. For this we are going to say country average age. We are going to use head 10 for getting less data this time, and I will say plot, and let's set kind as bar, and let's give a title to this. We are going to say top, also I need to write title correctly, top 10 countries with highest average age of participants. And now we are going to set X label as country and Y label as average age, and we will set X text, and we will say rotation is going to be equal to the 45 plt.show at the end. Seems great, but let's change this. What if we don't want to take the top 10 and the bottom 10 instead? Let's just brainstorm. So we are just going to use tail instead of head here for getting the last 10, and let's change this with lowest. And now we are going to see the information that here our information. Also we can say like 15 here for getting the least 15, and here it is. You can make changes like this for the information that you want to get. Okay, now let's do another thing. Let's group by season and plot the distribution of ages. For this we are going to say let's use box plot this time. Data is going to be equal to data, and X is going to be equal to season this time. And by the way, it's first time I think we are using season in visualization, and we are going to set the Y age here, and we are going to use plt.title distribution of age by season, and we are going to say X label season and Y label age here, and we are going to use plt show. Here it is. Okay, I liked using different type of plots, so let's use violin plot this time. We are going to group by medal and display the distribution of heights this time by using a violin plot. For this I'm going to say SNS violin plot, data is going to be data, and X is going to be medal, Y is going to be height, and let's say palette set to, let me quickly fix the typo I made. And I think we are cool. We don't have a typo here. Let's say X. Let's set the title firstly, distribution of heights by medal, and let's add X label like medal and Y label like height, and we are going to say plt.show here. That looks great. Okay, now what we are going to do is let's retrieve the most medal winning country. For this we are going to say most medals. We find the information about the gold, but we didn't find the information about all of them, like the sum of the three, but I'm sure it's going to come up with the United States. We are going to say data country here, and we will use value counts, and we will take the maximum index here, and let's print like most medal winning country, and use like this, and let's just print this. Here it is, like we expected. Okay, let's retrieve the tallest athlete. For this, we are going to say tallest athlete data height equals to data height, the maximum value of this column. Here it is, and let's print tallest athlete, and let's print tallest athlete ID, name, and height. Also, I want to retrieve the sport here. I'm pretty sure it's going to return basketball, and let's just run this. Here it is, as we expected. Seems great. So let's do another thing. Let's retrieve the athlete with the highest weight value. For this, we are going to say heaviest athlete. Let's say data is going to be data weight, same thing actually, equals to the data weight and also maximum value of it. And we are going to say print heaviest athlete. Let's just don't capitalize it, and we are going to say heaviest athlete, and we are going to open two brackets like this. We will say ID, name, weight, and let's retrieve the sport again for this athlete, and let's just run this one. It returned two of the same entries, but we cleaned duplicates, remember it, so they are not duplicate actually. This means that this athlete competed 2 times and has the highest weight value. So let's just also, I'm going to show you how we can take the minimum, and we are just going to change this, and we can do this, like not change this actually, and we can see that this time it returned 6 entries, but all the same person. I think he or she competed 6 times. That's why we are getting this type of return from our code. Okay, let's do another thing. Let's create a scatter plot. We are going to use height and weight here, and our hue is going to be metal this time. This is going to be returning height and weight combinations of the athletes with medal winning information. For this, we are going to use seaborn scatter plot, and we are going to say data is data, x is height, y is weight, and hue is medal. And we can add a palette here, like let's use set1, and here it is. Let's give a title for this, plt.title, and we will say athlete height versus weight by medal, what we can say status here. Okay, x label is going to be equal to the height, and y label is going to be equal to the weight, and let's add legend. Title is going to be, let's say, medal, and we will use plt.show here. This is our code for this. Seems great, seems really colorful, right? Okay, let's do a final thing, and then I'm going to finish the video, because I think we did a great job on this analysis. We answered a lot of questions, we created a lot of plots, and I think this was a good data analysis video. So let's create a heat map of medals by country and year this time. This time we are going to create a pivot table to calculate medal counts by country and year. For this, we are going to say medals by country year. It's going to be data.pivot table, and index is going to be the country here, and columns are going to be equal to the year, and values going to be medal, and we also need to give the aggregate function here, which is count. I think it's the structure that we need here. Now it's time to create the heat map. For this, we are going to say SNS heat map, and medals by country year Cover map, let's say, why I know this one because I used it before. You can look for others, and also set line width 0.5 and give a title to our heat map, medal counts by country and year, and let's set X label as year and Y label as country, and let's set X text rotation 45 and plt.show. Here it is. Since we have a lot of values, it's maybe we can change the cover map here and we can make a change on the output. I think this one is more informative, but since we have a lot of values, Heatmap isn't showing us a lot of things here. I just want to show how it's applied with pivot table, and that was the final thing for our video. Thank you for watching my video. I hope you found it informative and helpful. I'm creating similar content like exploratory data analysis videos, courses about data visualization, data analysis, big data applications and machine learning. So for more data science content, you can subscribe to my channel. Have a great day.